Alright, welcome everybody. This is video 2 for those of you following along with the video. Hopefully by now you've already printed off your study guide to go along with this so you can fill it in as we go. Um, this video is going to focus on the second portion of our online schedule, the HVAC component identification and operational theory. So let's get rolling. Alright. So the online objectives for this course, basically by the end of it, we're going to hopefully be able to understand the basic theory of heavy-duty air conditioning systems, outline the requirements of the Clean Air Act that apply to heavy-duty air conditioning systems, understand basic component identification and operation, and understand the safety and its effect on the ecosystem in accordance with the EPA, the SNAP program, the good, just regular good mechanical practice, and of course, OSHA. All right, so heating, ventilation, and air conditioning, in other words, HVAC systems, are designed to keep the cab in a vehicle at a comfortable temperature. Like I said earlier in the objectives of this slide, that we're going to start off pretty easy. I hope you're ready for this because that's as simple as it gets right there. Uh, wouldn't you be surprised to understand that the AC system is supposed to keep the cab cold? Woohoo! All right, so moving on. The air conditioning system also helps keep the cab clean. It conditions the air, so that means it takes the dust, the pollen, the smoke, and then the moisture all out of the cab as well. Uh, and then we're going to talk about temperature. Actually, I think we get into it the next slide. It actually removes the heat from the air. So it takes everything out. It doesn't really put anything in the air, it just takes stuff out. All right, so how is air conditioned in the cabin? Yep, here it is, right here. Takes the moisture out, takes the heat out. This is kind of, I mean, all of these are important, but this is the one I want to focus on. An AC system is not a cooling system. It's not putting cold air into the cab. It's removing the heat from the air that's already in the cabin. That's very important to understand, especially once we get farther into this. It's taking the heat out because heat always transfers to cold. If you light a match in one corner of the room, um, over time, that heat is going to disperse across the room. Uh, the cold isn't going to move to the match. The heat is going to move across the room. That's important to remember that as we're talking about air conditioning because your cab is not blowing cold air. It's removing heat, and the effect is cold air gets blown out of the event. But then we also remove pollen dust. Um, so this is our evaporator. This is basically the cold unit inside the cab. So when air starts to blow through, it removes the heat from the air and it puts it inside of the evaporator. It's got freon traveling through there. That heat gets sucked into that freon. And then out comes cool, clean air. Now, the cleanness, typically right here on the front side of this evaporator, right in this section, right here, uh, you're going to end up with a filter. And I don't know, many of you have probably seen these filters. They're just a bunch of fibers, really. But those filters, they really get plugged up, especially if somebody has a lot of animals, like they have a dog they like to let ride with them or whatever. Oh, they get nasty, gross, and they'll plug up, and they'll basically the effect is you're going to start getting a lot of hot air blowing through, or no air at all blowing through. And complaints of, hey, my AC is not working. One of the first things you always want to check are these filters. They're pretty standard for plugging up. The more common one to plug up than this one here, this is, like I said, inside the cab here. There's also an external. When you're bringing air from outside into the cab, that one plugs up another filter, and it plugs up with dust even more often for obvious reasons. I mean, especially in a tractor 5 mile an hour, back and forth through a field kicking dust cloud 30-mile high. what do you expect? It's going to plug that filter with dust. So you always want to check your filters. They're just quick fiber filters. Pull them out, make sure they're not all plugged up, and replace them if need be. All right, so when we're working on AC systems, when we're working on AC systems, there's one thing we have to understand, and that's the laws of thermodynamics. Thermodynamics is nothing more than the study of heat. So scientists use this for all kinds of things. Well, it plays a lot in AC systems. I mean, we're removing heat from a cab, so we need to understand at least a basic understanding of how it reacts and why it reacts that way. So once again, heat always travels from hot to cold. If you ever have a hot area and a cold area, heat will travel to the cold area. Um, Latent heat is the heat energy required to change a substance from one state to another. So an AC system, it focuses more on state of matter and pressure than it does temperature. Temperature is an effect. So we're removing the heat from the cab as an effect because we're changing the pressure inside of the AC system, which in turn causes a state change from a liquid to a vapor, which then causes the heat to be removed, which we're going to get into that in a lot more detail. But just for now, just remember that heat travels to cold, and latent heat is the amount of energy required to change one substance from one state to another. Latent heat of vaporization, once again, is kind of the same thing, is the heat energy required to change a liquid to a vapor without raising its temperature. And then the amount of heat energy required to raise 1 pound of water by 1 degree Fahrenheit is known as a BTU. BTU is kind of a standard measurement. Joules is another standard measurement, basically nationwide. Everybody uses both of these. Um, and it's just the amount of energy that's necessary to raise the temperature by 1 degree. Now, obviously, as we're working on an AC system, we're the outcome, the goal is to change temperature. So knowing the amount of BTUs necessary to put in based upon the pressure that is on the system, based upon the state that the liquid or vapor freon inside the system is going to change the outcome clear through. So once again, this is kind of getting back into that closed circuit situation, but this will get more and more easy to understand as we move along. So this is just kind of the pointers right now. This is the stuff you need to know. Take notes on it. It'll come back up later as we're going through this stuff. All right, so visual examples. So let's look over here. Right here is a visual example of a BTU. You have your amount of heat necessary to raise 1 pound of water by 1 degree Fahrenheit. Right there. So if you didn't catch that the first time, so your latent heat then is the amount of heat that is absorbed when taking a liquid to a vapor, or the latent heat is the amount released when taking a vapor to a liquid. So a couple years ago, I saw a guy explain latent heat using a can of ether, and many of you have used ether before. When you press it, the can gets really cold in your hand. And the reason that is because inside this can, you have a liquid and it's under extreme high pressure, right? If you were to poke a hole in this can, it would blow out. So when you open the can by pushing down and you get that little hole, releasing out the liquid is actually turning because of the lack of pressure, the lower amount of pressure, atmospheric pressure being lower than the pressure inside the can, the liquid is turning into a gas or a vapor. And when that happens, you are actually absorbing that latent heat. So where's that heat coming from and what's absorbing it? That's the next question. Basically, as it transfers from a liquid into a vapor, it's pulling the heat around the outside of the can or inside the can itself, any heat that it can get to, because in order for it to make a change to a vapor, it has to absorb heat. So it pulls the heat out of the can in order to create a vapor. So, I mean, if it was possible, if you didn't run out of liquid before it happened, you could actually freeze one of these cans over before you released all the fluid, but it'd take a fairly substantial can in order to do that. Big. So anyway, um, as liquid changes to a vapor, it absorbs heat and it's putting that heat out in a vapor form. It's not actually hotter coming out as a vapor, but it's needed that heat to make the transition. So it used that heat to create a transition or a state of change from liquid to vapor. All right, so moving on from latent heat. All right, so pressure and heat, pressure versus heat. Um, I'm sure some of you have heard this before. The higher or the more pressure you're in, the less chance of something is to boil. So if you're up in the mountains, you got a lower atmospheric pressure, right? So water's supposed to boil faster. If you were to uh, put a bowl of water inside of a decompression chamber. I'm sure some of you have seen those before. Uh, Obviously, divers use decompression chambers and stuff, but they make little ones as well. You can put a bowl of water inside of there and simply just decompress the air out of inside of there, and the water will start to boil. Because a lower pressure, atmospheric pressure, will lower the boiling point. So you could potentially lower the boiling point all the way down to 70 degrees Fahrenheit, and the water will start to boil just by changing the pressure. And that goes both ways. If you increase the pressure, just like in a radiator system, a coolant system, we increase the pressure by 14 psi inside that radiator, which in turn increases the boiling point. We run that same issue, or we run that same system in the AC as well. And if we look at our can of ether, inside we have a high pressure holding our starting fluid itself at a liquid. But as soon as we release it to atmospheric pressure, it boils off, it becomes a vapor. So pressure, in this case, increased the boiling point so that it's not becoming a vapor until it's released to atmosphere. All right, so key things to remember as we're going over AC stuff is heat always moves from a warmer area to a cooler area, so it's transferred from hot to cold. Um, when liquids are heated and evaporated to a vapor state, heat is absorbed, and when gas condenses from a vapor to a liquid state, heat is released. All right, so this is a truck air conditioning system. Um, if I get the can equips information. Hopefully Doug will be sending that to me. Then you won't even see this part of the video because I'll change it over to the tractor or combine or whatever it is he sends me. But just in case I don't get that, we'll go ahead and talk about this on the truck side. Same system, exact same. The only difference is it's on a truck instead of a tractor. So not a problem. So basically what we're looking at on this system, right here is a compressor. And that compressor is going to build up the pressure uh, of the freon inside the system. That freon is going to travel through the condenser, come out the condenser. The condenser's basically its main job is to remove the heat from the system. Come out of the condenser. I say heat. We'll get to that later. It actually changes the state of matter. Comes out of the condenser, goes to the receiver dryer. As soon as my mouse comes alive so you can see it, there you go, goes through our receiver dryer. That does exactly what you think it would do. It dries, so it gets rid of the water out of the freon. After it leaves the receiver dryer, there's my mouse again, travels up here and it goes through this component right here. Basically, this is a metering unit. That can be a number of different things. It could be an expansion valve. It could be a capillary tube. There's a few different options here. Used a lot of variation, The newer ones are typically all your thermostatic expansion valves. We'll get into multiple systems, different types of